Now, since we are done with adding and subtracting decimals, the next thing is multiplying decimals, and our learning target is definitely the same for indicator 5. I can fluently perform operations with decimals. Please remember, operations basically means PEMDAS. Because order of operations, so adding, subtracting, multiplying, dividing, whatever operation you're using, that's what it means. Decimal is any number which has a fractional part. Okay, and then we know that a whole number is a number that does not have a fractional part behind it. So it does not have a decimal or a fraction, in it. But in a decimal, what separates it is because there is going to be a fractional part. Okay, so multiplying decimals. There is a very, very important step that I would like you to remember when we begin this. So let me start with decimal times a whole number first. Okay, so here's the decimal, here's a whole number, and I'm saying whole number because there is no decimal part or fractional part attached to this number. Okay, like in addition subtraction, the aligning of the decimals was such a big part of that lesson. In this, it doesn't matter. Okay, you do not have to align decimals in multiplication. So I'm going to write this out as 2 and 8/10 times 5. So look what I mean, but you don't have to align. 5 doesn't have a decimal because it's a whole number, but I do not need to align in multiplication. Now, here is the key step. And, when we just have a decimal, with a whole number, it's pretty simple where the decimal goes. But this, I need you to get into the habit of doing this so that when you're doing decimal times decimal, you do not make the mistake which I'll be showing you when we get to that. Okay, so the first and most important step, guaranteed if you don't do this, you will make mistakes. And a decimal moved once, even like in one place value, the whole answer is correct. Okay, think of it this way. If I say or if I say, see how much of a difference it makes. I'm sure all of you would rather have $5,000 than only $50. Okay, because look what the decimal does. This is a whole number, and that means my cents would have gone behind. So that's $5,000. This is $50. Decimal makes all the difference as to what that number is. So you've got to be very, very careful where you place that decimal in multiplication. Okay, so the first and most important step to remember so we don't make mistakes is you count how many digits are behind the decimal. So if I look at the decimal here, behind the decimal is the 8/10, so I have one digit here. Okay, that's one digit. And you can write like, you know exactly because we have one decimal place over here. That's basically what this means. Okay, this is just one decimal place. But if you just write that one, that's fine. After this is a whole number. So we don't have any decimal. There's nothing behind the decimal. So I'm going to write 0. Okay, and then you add these two up, and we have 1 here. Circle this so that we get back to this at the end. Okay, so now we are going to multiply, and 5 times 8 is 40. Carry over the 4. 2 times 5 is 10. Plus 4 gives me 14. Now I come back to this step. Okay, so this says 1. So then I start at the extreme right and I move 1 place value to the left. So my final product, because answer to a multiplication problem is called a product, my final product is 14. You can write 14 or 14 and 0/10 is the same thing. Okay, so please remember that first step. Now, this is with a whole number. Now, this comes very handy to write that first step when we come to problems like this, because I'll tell you what kids normally do otherwise. Okay, so if I say 4 and 8/10 times 7 and 2/10, please remember your first crucial step. You're going to count how many digits are behind the decimal. Okay, so in this case, I have 1. This is 1 digit behind the decimal. And then in this also, I have 1. So I'm going to write 1 over here. Add them up. Total amount is 2 digits. Okay, now next I am going to do the multiplication. So 2 times 8 is 16, carry over 1. 2 times 4 is 8 plus 1 and I get 9. Okay, now next we have to, since we're coming down to the next level, we're going to put a placeholder. Okay, and so we are going to annex a 0 over here, and then I know that 7 times 8 is 56. I'm going to carry a 5. Okay, and then 4 times 7 is 28, and plus 5 gives me 33. Okay, now once I have this, I am going to add over here. Annex your zeros here, because remember we are adding now. And then here we go. 6 plus 0 is 6. 9 plus 6 is 15. Carry over 1. 3 plus 1 is 4. And then 3 plus 0 is 3. Now, let me tell you, the biggest mistake that students make if they have not counted the digit. Guaranteed you're going to do this if you're not careful. Just because in addition and subtraction, you are used to carrying down the decimal straight down. This is what children actually do. Again, this is a big no-no. Okay? So what they do is they look at this and they go all the way straight down and they put the decimal here. Okay? They put the decimal over there. Guys, that is so incorrect. Okay? That means 345 and 6/10. This is so wrong. This is not how you're supposed to do it. This is where this comes in. So as I can see, there are 2 digits behind the decimal. So now I'm going to start at the complete right, and I'm going to go 1, 2. So this is where the decimal should be. Okay? And so my answer is 34 and 56 hundredths. My product is that. So look at the difference. If you had just pulled the decimal down, it would be 345 and 6/10, which is so different and such a bigger number compared to 34 and 56 hundredths. Okay, so be careful with that. Another thing that you can definitely do in order to prevent any mistakes is go ahead and do an estimation in the middle, so in the beginning, so you know as to how much your product should be about. Okay, so if I had done estimation, I would have rounded. When I'm saying rounded, remember the rule for rounding. If it is 5 or up, it goes up to the next number. If it is less than 5, then the number stays the same. Okay, so if I had done an estimate over here, and even like, when I'm looking at this, if I'm looking at 4 and 8 tenths, now I know 8 tenths is greater than 5. So this number would round up. So the 4 and 8 tenths, the 4 will become a 5. Okay, so if I had done 5 times, now we know that the 2 is less than a 5. So therefore, the number remains the same. So it would just become 7 because we are rounding here. So 5 times 7 gives me 35. So this is my estimate. And then when you look at the final product, you get 34 and 5600. If I was rounding this, it would become 35. So yes, the answer is pretty close to the estimate. So this is correct. Always do that, because think about it. If you had got 345 and 610, that was nowhere close to your estimate. So you would have known that you had done something wrong. Okay, so be careful. All right, let's try another one, which is written out over here. And so if I have 3 and 1/10 and I have 500, my suggestion, it doesn't matter because multiplication has commutative property. That means if I say 5 times 6, I can also write it as 6 times 5. Both mean the same thing. So that's called commutative property of multiplication, and my product will be the same. If 5 times 6 is 30, 6 times 5 is 30. I can write it either way. So same thing with a number like this. Either I write 3 and 1/10 times 500, or I can write 500 times 3 and 1/10. So I always advise my students in multiplication, always take the number with more digits and place it on the top level. And then the number with less digits, put it on the next level. So it becomes a lot easier when you are multiplying. Okay, so in this case, this has 2 digits. This has 3 digits. So because the 3 digits is more than the 2 digits, I am going to place 500th on the top. Okay, make my multiplication a lot simpler. So I'm going to write it like this. This is 500 times 3 and 1/10. Remember that in multiplication, aligning of decimals does not matter. Okay, now if I was to estimate this, just so that you know that later on you don't make mistakes. If I'm doing 3 and 1/10, I look at 3, I look at the number to the right of 3, and the number to the right is less than 5. So therefore, for estimation, this is going to become a 3. It's going to stay the same. And then if I look here, I'm looking at this part, and I'm looking at this part because I'm rounding to the nearest whole number. And so both are 0, so this stays the same. And so therefore, my product should be somewhere close to this number. Okay, because here I was rounding to the nearest whole number, obviously, in order to see what my product will be. Now let's do the actual math. Remember, your first step is to count how many digits are behind the decimal. Do not forget this first step so that we don't make mistakes at the end, okay? So we have 2 digits here, and we have 1 digit here. 2 plus 1, I get 3 digits total. So I'm going to hold on to that because I'm going to come back to this at the end, okay? So 1 times 5, 5. 1 times 0, 0. 1 times 0 is 0. Okay? Next level, place holder needs to be put. I'm going to annex that 0. And then I'm going to do 3 times 5 is 15. Carry over 1. 3 times 0 is 0 plus 1 is 4. Is 1. Because I said 3 times 0 is 0. plus 1, that gives me 1. And 3 times 0 is 0. Okay? So now, when I get this, I am doing addition now. So remember, any empty spaces, I am annexing a 0. And then I add, and then you get 5 over here, and 0 plus 5 is 5, 0 plus 1 is 1, and then 0 plus 0 is 0. Okay, so now we come back to this part where I'm looking at, okay, there are 3 digits. So I start on the extreme right, and I go 1, 2, 3. And this is where I place my decimal. So my final product is 155 thousandths. And so if you look at, if I was rounding this to the nearest whole number, look, 1 is smaller than 5, so this would round to 0. And if you're looking at the estimate, that is 0. So I know that this product is correct. Okay, so this is how you check your work. Now, let's do one last problem. And if I give you something where you're evaluating expressions, and we'll get into expressions and equations and all that thing, all that stuff later on. But right now, I'm just going to show you. There's a different unit completely on that. That's what I mean. So an expression is something which is not an equation, does not have the equal to sign. And we'll talk in depth about this later on. But let's say you are evaluating an expression which is 2 and 4/10 x. All right, so if I'm giving you something like this, find the value of x, and then it gives you certain values. For example, if I say x is equal to 3 and 95/100. Okay, now we'll get more in depth completely into this because there's an entire lesson on expressions and equations. But I just need to start thinking of certain vocabulary terms when I give you something like this. The number written right before the alphabet is called coefficient. This is called coefficient. And the alphabet that is there is called the variable. Okay, these are very important terms to remember. Coefficient always comes before the variable. We don't write x 2 and 4/10. It's always the number before the variable. So that coefficient is always written before the variable. Now, when numbers are written like this means multiplication. So this actually means 2 and 4/10 times x. But when we are writing it algebraically, we do not put that times. All you do is write the coefficient and variable, and that means multiplication. But this is what it's actually representing. Okay? Now, I said x is 3 and 95/100. So because x is that much, I am just going to substitute the value for x. And this is going to be 2 and 4/10 times, we said x is 3 and 95/100. Okay? And now once we have that, we are going to do the multiplication. So, if I was rounding, if I was estimating, let's see what my answer should come to if I was estimating. So 2 and 4/10, 4 is less than a 5, so this is going to stay the same. All right, so my whole number is 2 times, we look at the whole number and we look at the number to the right of the whole number. 9 is greater than 5, so we are going to round the 3 up to a 4. Okay, and 2 times 4 is 8, so my product should come to around 8. Okay, when I do the actual math. So let's go ahead and now look, 3 and 9500th has more digits than 2 and 4/10. So for convenience of multiplication, I am going to put it on the top because multiplication has commutative property. Okay, times 2 and 4/10. All right, remember the first step, and in this I am writing how many digits are behind the decimal, how many digits are behind the decimal. Here there were 2, here there is 1. So 2 plus 1, and that is total amount of 3, which I will get back to that when I have finished multiplying. Okay, so now let's start this. 4 times 5 is 20, carry over 2. 4 times 9 is 36 plus 2, and so I get 38, and I carry this over. 4 times 3 is 12, plus 3 gives me 15. Okay, so when you have done this part, go ahead and erase this so that we don't confuse about the carrying over and all on the next step. Okay, so now let's go to the next step. We have got to annex a 0, put the placeholder over here. Okay, and then we go here. 2 times 5 is 10, so we carry over 1. 2 times 9 is 18, plus 1, that gives me 19. Okay, and I carry over 1. 2 times 3 is 6, plus 1, and that gives me 7. Okay, now I'm just going to add. So I have 0, I have 8, I have 9 plus 5, that gives me 14. I carry over 1, and I get 7 plus 1 is 8 plus 1. This is not the number. Do not forget at this point to add the decimals. Okay, so this is where we look here. 3 digits, start on the extreme right and go 1, 2, 3. And so my quotient is 9 and 480 thousandths. I can also write it as 9 and 4800. Means the same thing. All right, so let's look at this. When I say 9 and 480 thousandths, yeah, it is pretty close to the 8. I'm not getting 94. I would have got that if I had moved the decimals incorrectly, or 948. My goodness, so that's a big difference. So if I'm seeing it is close to 8, I have done the math properly. Okay, so this is all about multiplying decimals. Please remember the key rules. And the next part of indicator 5 will be dividing decimals. All right, see you later.